This video is for those of you who are going to take algebra. So this is just an introductory course. Let's go over the basics. Let's talk about multiplication. If you want to multiply 5 times 4, what's the answer? Now perhaps you know the answer by memorization. But when you think of multiplication, think of repeated addition. 5 times 4 means that you're adding 5 4 times. 5 plus 5 is 10, and these two 5s add up to 10. 10 plus 10 is 20. So that's multiplication. It's just repeat addition. So if you want to multiply 8 times 3, basically you're adding 8 3 times. 8 plus 8 is 16. 16 plus 8 is 24. Division is the opposite of multiplication. For example, we said that 8 times 3 is 24. Therefore, 24 divided by 3 is 8. Now let's say if you want to divide 48 by 4. What does that equal to? So ask yourself, 4 times what number is 48? If you know your multiplication tables, 4 times 12 is 48. You can also use long division to get the answer as well, whenever you need to divide fractions. 4 goes into 4 one time. Bring down the 8. 4 goes into 8 two times. And so the remainder is 0. So 48 divided by 4 is 12. Now let's review exponents. What is 4 raised to the third power? What does that mean? When you're dealing with exponents, you're dealing with repeated multiplication. 4 to the third power means that you're multiplying 3 4s together. 4 times 4 times 4 is 64. So 5 squared means that you're multiplying 5 2 times. 5 times 5 is 25. Now what is the difference between negative 3 squared and negative 3 squared? So in a typical algebra class, make sure you understand the difference between these two. Negative 3 squared in parentheses means that you're multiplying two negative 3 values. A negative times a negative is a positive number. 3 times 3 is 9. Now, negative 3 squared without the parentheses means that you have one negative sign and you're multiplying two positive 3 values. So overall, this answer is negative 9. In addition, anything raised to the 0 power is 1. Now, when dealing with variables, when you multiply common variables, you can add the exponents. X squared times x cubed is x to the 5th. So basically, x squared means that you're multiplying two x values. X cubed, 3x values. So in total, you have 5 x variables being multiplied together. Now, what is x squared raised to the third power? When you raise one exponent to another exponent, you need to multiply. 2 times 3 is 6. So this expression means that you have x squared times x squared 3 times, which each x squared is x times x. So in total, you're multiplying 6 x variables, and that's why it equals x to the 6. Now, what about dividing? Let's say x to the 7th divided by x cubed. What does that equal to? So when you're dividing, what you need to do is subtract the exponents. 7 minus 3 is 4. To understand it, x to the 7 equates to 7 x variables being multiplied together. X cubed represents 3 x variables. So if you cancel 3 on top, 3 on the bottom, notice that you'll have 4 left over on top, so x to the 4th. Now you need to be familiar with negative exponents. X to the negative 3 is the same as 1 over x cubed. So if you move the x variable from the top to the bottom, the exponent changes sign. It changes from negative 3 to positive 3. So x to the negative 4 is 1 over x to the 4th. Likewise, if you have a negative exponent on the bottom, you can move the x variable to the top, and this will become positive x squared. So let's say if you want to multiply 4x cubed by 5x to the 6. Let's multiply 4 times 5. 4 times 5 is 20. And then we need to multiply x cubed times x to the 6, which we need to add 3 and 6, that's 9. So it's 20x to the 9th. So go ahead and work on these examples. 5x to the 4th times 3x to the 7th, and 24x to the 8th divided by 6x to the 5th. So 5 times 3 is 15, and x to the 4th times x to the 7th, we need to add 4 plus 7, so that's 11. Here we need to divide. 24 divided by 6 is 4. And x to the 8 divided by x to the 5th, we got to subtract 8 minus 5, so it's 3. So you get 4x cubed. Here's another example. Simplify this expression. 28x to the 4th divided by 35x to the 7th. Feel free to pause the video. Now in this example, I'm going to break down 28 into 7 and 4. 35, I'm going to break it down into 7 and 5. X to the 7th, I want to write it as x to the 4th times x to the 3rd, because 4 plus 3 adds up to 7. Notice that I can cancel a 7, and I can cancel x to the 4th. So the final answer is 4 divided by 5x cubed. Now granted, you could have subtracted 4 and 7. 4 minus 7 is negative 3. Now it's x to the negative 3 on top, but if you move it to the bottom, it becomes 1 over x cubed. So in the end, you should have x to the 3rd on the bottom. Here's another example that's similar. Let's say if we have 63 x to the 4th, y to the 3rd, over 56 x to the 8th, y to the 5th. 63 is 9 times 7. And 56 is 8 times 7. X to the 8th is x to the 4th times x to the 4th. Y to the 5th is y squared times y cubed. 2 plus 3 is 5. 4 plus 4 is 8. And then I'm going to cancel the 7. I'm going to cancel x to the 4th. And I'm also going to cancel y cubed. So my final answer is 9 divided by 8x to the 4th y squared. So that's a nice and simple way to simplify expressions that look like that. Now sometimes you may have to deal with exponents. Let's say if you have 2x cubed y to the 4th raised to the 3rd power. How can we simplify this expression? So when you raise one exponent to another, you need to multiply. So first we're going to multiply 3 by 1. 3 times 1 is 3. And then 3 times 3, which is 9. And 4 times 3, which is 12. 2 to the 3rd power means that we're multiplying 3 2's together. 2 times 2 times 2 is 8. So the final answer is 8 x to the 9th, y to the 12th. Try this one. 3x squared y to the 3rd raised to the 2nd power times 4x cubed y to the 4th raised to the 3rd power. So let's distribute 2. 2 times 1 is 2, so we're just going to have 3 squared. And then 2 times 2 is 4, so that's going to be x to the 4th. And 3 times 2 is 6. And then we have 3 times 1, which is 3. And then 3 times 3, that's 9. And finally, 3 times 4 is 12. 3 squared is 3 times 3. 4 cubed is 4 times 4 times 4. X to the 4th times x to the 9th, we need to add 4 plus 9, so that's 13. And y to the 6th times y to the 12th, we have to add 6 and 12, which is 18. Now 3 times 3 is 9. 4 times 4 times 4 is 64. So what is 9 times 64? If you don't want to use a calculator, here's what you can do. You can multiply 64 by 10 minus 1, because 10 minus 1 is 9. 64 times 10 is 640, and 64 times 1 is 64. Now I'm going to write 64 as 40 and 24, because 40 plus 24 is 64. So negative 40 and negative 24 is negative 64. 640 minus 40 is 600. And if you take away 24 from 600, you can view 24 as 20 and 4. 600 minus 20 is 580, and 580 minus 4 is 576. If you want to subtract things in your head, that's how you can do it. So this is 576, x to the 13th, y to the 18th. Or, if you just want to do it by hand, you can do it this way too. 4 times 9 is 36. Carry over the 3. 9 times 6 is 54. Plus 3, that's 57. So you get 576. Now let's talk about simplifying algebraic expressions. Let's say if you have 3x squared plus 5x plus 7, and you wish to add it to 5x squared plus 3x minus 8. So how can you do so? So here we're adding polynomials. A polynomial is simply an expression with many terms. 8x is a monomial, which represents one term. 5x squared y cubed, that's also a monomial. It's a single term. 3x plus 5 is a binomial, because 3x is one term, 5 is another, and so you have two terms. A positive or a negative sign separates different terms. The expression 5x cubed plus 8x minus 7 is a trinomial, because there's three terms. And if you have many terms, you can call it a polynomial. Poly means many. So in this example, we're adding two trinomials. So what we need to do is add like terms. 3x squared plus 5x squared. What is that equal to? When you're adding like terms, you should only add the coefficients, but the variable does not change. So 3 plus 5 is 8. Notice that you don't change the exponent. If you're multiplying, then the exponent will change. For example, 3x squared times 5x squared is 15x to the 4th. But when adding and subtracting, the exponent does not change. But when multiplying, it can change if you're multiplying or dividing. So 3x squared plus 5x squared is 8x squared. They're like terms. By the way, we can't add 3x squared and 3x because they're not the same. If you try to add them, let's say 3 plus 3 is 6, are you going to use x squared or x to the first? You see, it doesn't match. So you can't add 3x squared plus 3x. They're not like terms. You can, however, add 5x and 3x. They are like terms. That's 8x. And then 7 plus negative 8, which is the same as 7 minus 8, that's negative 1. So that's the answer. Let's try another example. Go ahead and add these two polynomial expressions. Feel free to pause the video and work on the example. So first, let's add 5x cubed plus 8x cubed. 5 plus 8 is 13. And then let's add 7 and negative 4. 7 minus 4 is 3. So we're going to have 3x squared. And then we have 6x plus 9x, which is 15x. And then negative 3 plus 4, which is the same as 4 minus 3. That's positive 1. So now you know how to add polynomial expressions. Now what about subtracting polynomial expressions? Let's say we have 8x squared plus 5x minus 4 minus 3x squared minus 7x minus 9. So what do you think we should do? Before we subtract, we should simplify. There's nothing in front of this parentheses on the left, so we can just rewrite it as 8x squared plus 5x minus 4. Now this negative sign, we need to distribute it to all three terms. So positive 3x squared will now become negative 3x squared. Negative 7x will change to positive 7x. And negative 1 times negative 9, that's positive 9. So you can view this as the negative 1 being multiplied to all three things inside. Now let's combine those two. 8 minus 3 is 5. And then these two are like terms, 5x plus 7x, that's 12x. And then we have negative 4 plus 9, which is 5. So the answer is 5x squared plus 12x plus 5. Let's work on one more example. 7x cubed plus 6x minus 9 minus 9x cubed minus 5x squared plus 8. So let's rewrite the first part. That's simply 7x cubed plus 6x minus 9. Here we need to distribute the negative sign. So it's going to be negative 9x cubed plus 5x squared. And then negative 1 times 8 is negative 8. Now let's combine like terms. There's no similar term to 7x cubed. So we're simply just going to rewrite it. Actually, wait, I take that back. There is a like term. These two are like terms. So 7 minus 9 is negative 2. So we have negative 2x cubed. Now these two, they're not like terms, so we can't add them. So we're just going to write them. Positive 5x squared plus 6x. Now negative 9 and negative 8, we can combine those numbers. That's negative 17. So this is the answer. Now let's say if you were to see an expression that looks like this. 3x plus 4 squared. What is that equal to? Let me tell you what it's not. It is not 3x squared plus 4 squared. Don't do that. So I need to show you the difference between 4x y squared raised to the third power compared to this expression. Everything inside is multiplied to each other. 4 is multiplied to x, which is multiplied to y squared. There's no plus or minus sign in this expression. But here, we have a plus sign that separates the 3x and the 4 term. So when you're dealing with 3x plus 4 squared or something similar to it, you need to write it twice and FOIL. In this example, you don't need to FOIL. You can distribute the 3 to every exponent. So it's 4 cubed, x cubed, y to the 6, which is 64, x to the third, y to the 6. So you don't need to FOIL if there's no positive or negative sign that separates terms. But in this example, we do need to FOIL. 3x times 3x is 9x squared. 3x times 4, that's 12x. And then we have 4 times 3x, which is 12x. And finally, 4 times 4, that's 16. Now let's combine the two middle terms. 12 plus 12 is 24. So this is the final answer. Go ahead and try this example. What is 3x plus 5 times 3x minus 5? These two are known as conjugates of each other. The first two terms are the same. The only difference is one is positive, the other is negative. When you multiply a binomial by its conjugate, the two middle terms will cancel. So in this example, it works out to be 3x squared minus 5 squared. Only if they're conjugates. If they're not conjugates, you need to FOIL. But let's prove that this answer is correct. 3x times 3x is equal to 9x squared. 3x times negative 5 is negative 15x. 5 times 3x is 15x. And 5 times negative 5 is negative 25. So only if these two are the same, and if one is positive and if the other is negative, will the middle terms cancel. And so the final answer is 9x squared minus 25. Now let's talk about multiplying a binomial by a trinomial. So first, we're going to multiply 2x by x squared. And so this is going to be 2x cubed. And then we'll multiply 2x times 5x, which is 10x squared. And then 2x times negative 2, that's negative 4x. And then we need to multiply 3 times x squared, which is positive 3x squared. And then 3 times 5x, that's 15x. And then 3 times negative 2 is negative 6. Notice how I lined up the common terms. So there's nothing to add 2x cubed to, so we're just going to bring it down. 10x squared plus 3x squared, that's 13x squared. Negative 4x plus 15x is 11x. And then we could bring down the negative 6, so this is the answer. Now let's multiply a trinomial by another trinomial. So how can we do this? First, let's multiply 3x squared by 4x squared. So that's going to be 12x to the fourth. And then let's multiply 3x squared by 7x, which is 21x cubed. This is x squared times x to the first. 2 plus 1 is 3. And then we have 3x squared times negative 9. So that's negative 27x squared. So that's the first part. Now let's move on to the next one. That is 5x. So let's multiply 5x by 4x squared. So that's going to be positive 20x cubed. And then we'll multiply 5x times 7x, which is positive 35x squared. And then 5x times negative 9, that's negative 45x. Next, let's multiply negative 6 by 4x squared. And that's negative 24x squared. And then negative 6 times 7x, that's negative 42x. And finally, negative 6 times negative 9 is positive 54. So let's add. So this, we're just going to bring it down. The first term is 12x to the fourth. Now let's add these two. 21 plus 20 is 41. Negative 27 plus 35, that's positive 8. 8 minus 24 is negative 16. And negative 45 plus negative 42, that's negative 87. And so this is the answer. That's how you can FOIL two trinomials together. Now let's spend a few minutes talking about fractions, because you need to know this when taking an algebra course. Let's say if we have 3 over 5 and we wish to add 7 over 5 to it. The top part of a fraction is known as the numerator. The bottom part is the denominator. So if the denominator is the same, you can add the numerators of the fractions. So 3 plus 7 is 10. So this is going to be 10 over 5. When adding and subtracting fractions, the denominator doesn't change. 10 divided by 5 reduces to 2. So that's the final answer. So let's say if we have 8 over 3 plus 13 over 3, we can add 8 plus 13, which is 21. And 21 divided by 3 is 7. Now, what can we do if we don't have a common denominator? What if the denominator is different? How can we add these two fractions? Well, here's a quick and simple technique which works if you're adding or subtracting just two fractions. Multiply 3 times 3. That will give you 9. And then 4 times 5. That's 20. And then 3 times 4 is 12. So the answer is going to be 29 over 12. So that's a quick and simple way of doing it. But let me explain how that process works. What we need to do is get common denominators. So we need to multiply the first fraction by 3 over 3. Whatever you do to the top, you must also do to the bottom. Over here, we're going to multiply by 4 over 4. 3 times 3 is 9. 3 times 4 is 12. 5 times 4 is 20. And 3 and 4 is 12. Now that we have the same denominator, we can add the numerators. So 9 plus 20 is 29. So this is the answer. Here's another example. What's 5 over 6 minus 4 over 5? So let's get common denominators. Let's multiply this fraction by 6 over 6 and this one by 5 over 5. This will give us a common denominator of 30. 5 times 5 is 25. 5 times 6 is 30. 4 times 6 is 24. So 25 minus 24 is 1. So the answer is 1 over 30. Now let's combine 3 fractions. So in this case, we need to get a common denominator. We can use any common multiple, even the least common multiple. If you're not sure how to find the least common multiple, what you could do is multiply one fraction by the denominators of the other fractions and then simplify. So 3/4, I'm going to multiply it by 3 over 3 to get a denominator 3, and also by 5 over 5 to get the 5 as well. 2/3, I'm going to multiply by 4 and 5. That is by the other two denominators. And 4/5, I'm going to multiply it by 3 and 4, which is basically 12. Now 4 times 5 is 20 times 2, that's 40. On the bottom we have 4 times 5 times 3. 20 times 3 is 60. 12 times 4 is 48. 12 times 5 is 60. 3 times 3 is 9, and 9 times 5 is 45. So notice that the denominator is the same. Let's combine these two first. 48 minus 45 is 3. So we have 40 over 60 plus 3 over 60. And 40 plus 3 is 43. So the final answer is 43 over 60. So that's how you can add or subtract 3 fractions. Now what about multiplying 2 fractions together? When multiplying fractions, you can multiply across. 5 times 3 is 15. 7 times 4 is 28. So the answer is going to be 15 over 28, and we can't reduce it. Now let's say if we're dealing with larger numbers. Let's say if we have 18 over 24 times, let's say 21 over with a 35 on top. Now you can do the same thing. You can multiply across, but 18 times 35 is a big number. So when dealing with larger numbers, it's best to break down the large numbers into small numbers and then simplify before you multiply. For example, 18 is 6 times 3, 24 is 6 times 4, 35 is 7 times 5, and 21 is 7 times 3. So hopefully you know your multiplication tables. Now let's cancel a 6, we could cancel a 7, and we could cancel a 3. It turns out we don't have to multiply anything. So the final answer is what remains, 5 divided by 4. And that's it. Now what if we want to divide two fractions? How can we do so? Perhaps you heard of an expression called keep, change, flip. That is, keep the first fraction the same, change division to multiplication, and flip the second fraction. And then you can multiply across. 3 times 5 is 15, and 4 times 8 is 32. And so that's the final answer. There's nothing we could simplify in this example. So those are just some basic rules of fractions that you need to be aware of. Now let's talk about solving linear equations. Let's say that x plus 4 is equal to 9. What is the value of x? Now x is a variable. It represents a number with a specific value. In order to find it, ask yourself, what number plus 4 is 9? We know that 5 plus 4 is 9, so therefore x has to equal 5. Now, the work that you need to show in order to get the value of x is you need to perform the opposite operation of addition to undo the plus 4, or to move it to the other side. The opposite of addition is subtraction. If you subtract both sides by 4, the 4's will cancel. Positive 4 and negative 4 adds up to 0. 9 minus 4 is 5. So that's how you could find the value of x, and that is the goal of any equation. You want to solve the equation to get the value of x. Let's try another one. Let's say x minus 8 is equal to 7. What is the value of x? So in this case, you need to perform the opposite of subtraction, which is addition. 7 plus 8 is 15. And so that's the value of x. Now what if we have this? 3x is equal to 36. How can we find the value of x? This time 3 is multiplied to x. The opposite of multiplication is division. So you want to divide it by 3. 3 divided by 3 is 1. So on the left we have 1x, or simply x. X is the same as 1x. On the right, 36 divided by 3 is 12. And so that's the value of x in this equation. Now how about this one? X divided by 4 is 6. What is the value of x? So the opposite of division is multiplication. So therefore we need to multiply both sides by 4. So x is going to equal 6 times 4, which is 24. Now what if we have a fraction? 2x over 3 is equal to 8. What would you do? In order to find the value of x, multiply by the reciprocal of 2/3. That is, by 3 over 2. 8 is basically 8 over 1, by the way. On the left, the 2's will cancel, and the 3's. So you just have x on the left. On the right, you have 8 times 3 divided by 2. 8 times 3 is 24. 24 divided by 2 is 12. And so that's the value of x in this example. Now let's solve multi-step equations. Let's say this is equal to 17. What is the value of x? So the first thing we need to do is subtract both sides by 5. You don't want to divide both sides by 3 because you'll get 17 over 3, and that's a fraction. 17 minus 5 is 12. Now at this point you want to divide both sides by 3. 12 divided by 3 is 4. So x is equal to 4. Let's work on another example. Try this one. 2x minus 9 is equal to, let's say, 7. So let's begin by adding 9 to both sides. 7 plus 9 is 16, so 2x is equal to 16. To separate 2 from x, you need to divide. 16 divided by 2 is 8, so that's the answer. Now let's say if we have variables on both sides. What is the value of x? In this case, what we can do is combine like terms. Let's subtract 3x from both sides, and let's add 24 to both sides. Our goal is to get all the x variables on one side and all the numbers without x on the other side. So notice how the 3x and negative 3x will cancel, and negative 24 plus 24 is 0. So now we have 6 plus 24, which is 30, and 8x minus 3x, which is 5x. Now to separate 5 from x, we need to divide both sides by 5. 30 divided by 5 is 6. So that's the answer. Try this one. Let's say if we have 3, 2x minus 5 plus 4 is equal to 5x plus 2 times 3x minus 8. So now we have variables and parentheses on both sides. What can we do to find the value of x? The first thing you should do is distribute. Let's distribute 3 to 2x minus 5. 3 times 2x is 6x. And 3 times negative 5, that's negative 15. On the right side, let's distribute 2 to 3x minus 8. So 2 times 3x is 6x. And then 2 times negative 8, that's negative 16. So now let's combine like terms. On the left side, we can combine negative 15 and 4. Negative 15 plus 4 is negative 11. On the right side, we can add 5x and 6x, which is 11x. Now let's subtract both sides by 6x, and let's add 16 to both sides. Negative 11 plus 16 is 5. 11x minus 6x is 5x. And 5 divided by 5 is 1. So therefore x is equal to 1. What would you do if you have an equation that has a lot of fractions? What is the value of x in this case? What I would do is multiply everything by a number that's going to get rid of all the fractions. So what number is a multiple of 3, 4, and 6? 12 is a multiple of 3, 4, and 6. 12 is divisible by 3, 4, and 6. So we're going to multiply everything by 12. So what is 12 times 2/3 x? Now there's two ways you could find the value of 12 times 2/3. You could say 12 times 2 is 24, divided by 3 is 8. So you can multiply first and then divide. Or you could divide first, then multiply. 12 divided by 3 is 4, 4 times 2 is 8. So either case, the first term is going to be 8x. Next, let's multiply 12 times 1/4. That's the same as 12 divided by 4, which is 3. Now what about 12 times 5/6? 12 divided by 6 is 2, times 5, that's 10. And 12 times negative 3/4. 12 divided by 4 is 3. 3 times 3 is 9. But it's going to be negative 9 due to the negative sign. So now we could solve for x. Let's subtract both sides by 8x. And let's add 9 at the same time. 3 plus 9 is 12. 10x minus 8x is 2x. Now all we need to do is divide by 2. So 12 divided by 2 is 6. And that's the value of x in this example. So when you have fractions and you want to solve a linear equation, it helps a lot if you clear away the fractions first. Now let's move on to another example. Let's say if we have 0.5x plus 0.13 is equal to 0.26x minus 0.47. How can we find the value of x if we have a linear equation with decimals? So notice that we have some numbers that's rounded to the 100th place. If you see that, if you see 2 digits after the decimal point, you want to multiply everything by 100. If you only see 1 digit, multiply everything by 10. But since we have some numbers with 2 digits after the decimal point, use 100 to clear away all decimals. So 100 times 0.5x, that's going to be 50x. And 100 times 0.13, you just got to move the decimal 2 units to the right. So that's going to be 13. 100 times 0.26x is 26x. And 100 times negative 0.47 is negative 47. And now we can solve this like any other equation. So what I'm going to do is subtract 50x from both sides. And at the same time, I'm going to add 47 to both sides. (13 plus 47 is 60. 26 minus 50 is negative 24. So now I'm going to divide both sides by negative 24. So on the right I have x. On the left, 60 divided by 24. So let's simplify that. 60, we know it's 6 times 10. And 10, I'm going to write that as 5 times 2. 24 is 6 times 4. But the 4 I'm going to write it as 2 times 2. So we could cancel a 6 and we could cancel a 2. So 60 over 24 reduces to 5 over 2. So x is equal to negative 5 divided by 2. Now let's talk about inequalities. What does this expression mean? That expression means x is greater than 3. When you're dealing with inequalities, it represents a range of values rather than a single value. So this can mean that x is 3.5, x could be 4, x could be 50. X is something that is greater than 3, but not equal to it. To represent this answer on a number line, let's say this is 0 and this is 3, you need to use an open circle and need to shade towards the right. Because on the right side, you have numbers that are greater than 3, and x is greater than 3. But because it doesn't equal 3, you should use an open circle. Now let's say if x is equal to or greater than 4. In this case, x can be equal to 4. So we need to use a closed circle to include 4. But because it could be greater than 4, we're going to shade to the right. So that's how you can plot an inequality on a number line. What about these two? Let's say if x is less than 1 and if x is equal to or less than negative 2. So when x is less than 1, we need to use an open circle because it doesn't include 1. If you don't see the underline, always use an open circle. Now since it's less than 1, we need to shade towards the left. Now for the next example, where x is less than negative 2, but it can be equal to it, so we're going to use a closed circle and we're going to shade towards the left. Now how would you plot these two inequalities? Let's say if x is less than 2 or x is greater than 5. How can we plot this inequality? So there's two answers. The first part, x is less than 2, so we have an open circle and we're going to shade towards the left. The second part, x is greater than 5, so that's another open circle, but we got to shade towards the right. Now what about this one? Let's say if x is greater than or equal to negative 4, but less than 3. Go ahead and plot it. So here's negative 4, here's 0, and here's 3. So x is equal to or greater than negative 4, so we got to shade towards the right. But at the same time, it's less than 3, so it's in between these two values. It includes negative 4, so we have a closed circle, but it's less than 3, so we have an open circle at 3. Now let's spend a few minutes talking about how to solve linear equations with inequalities. So let's say that 3x minus 4 is greater than 11. Solve the inequality and then graph it on a number line. So we can solve this as any regular equation. Let's begin by adding 4 to both sides. So we're going to have 3x is greater than 11 plus 4, which is 15. And then we'll divide by 3. So 15 divided by 3 is 5. Therefore, x is greater than 5. So what we need is an open circle on 5 and shade it towards the right. And so that's it for this problem. Now what about this one? Negative 4x plus 9 is greater than or equal to, let's say, 11. Let's go ahead and find the value of x. So let's begin by subtracting both sides by 9. So 9 plus negative 9 adds up to 0. So we have negative 4x is greater than or equal to 11 minus 9, which is 2. Now we need to divide both sides by negative 4. Now here's what you need to keep in mind. When dealing with inequalities, whenever you multiply or divide by a negative number, the inequality changes direction. So in this case, instead of being greater than or equal to, it's now less than or equal to. 2 divided by negative 4 is negative 1/2. So we got x is less than or equal to negative 1/2. So let's say this is 0 and this is negative 1. Negative 1/2 is in between negative 1 and 0. It's right in the middle. And because it's less than, we're going to shade towards the left. And because it can equal negative 1/2, this has to be a closed circle. And so that's it. Try this one. 2x over 3 is greater than negative 4. Solve the inequality. So in this example, we got to multiply both sides by negative 3 over 2. So the 3's will cancel, and the 2's will cancel. And the 2 negatives will cancel, making this positive x. But anytime you multiply or divide by a negative number, the inequality changes direction. Negative 4 times negative 3 is 12, divided by 2, that's 6. So the answer is x is less than 6. So we need an open circle shaded towards the left because it's less than. Now let's talk about absolute value. What is the absolute value of 8 and negative 5? The absolute value will always produce a positive output besides 0. So the absolute value of 8 is 8. The absolute value of negative 5 is 5. Now let's say if you wanted to solve this equation. The absolute value of x is equal to 7. What is the value of x? In this case, x could be two possible numbers. It can be 7 or it could be negative 7, because the absolute value of 7 will give you 7. And if you plug in a negative 7, that too would still give you the same output, 7. So the absolute value function produces positive numbers. And the absolute value of 0 is 0. So it won't give you a negative output. Now let's say if we wanted to solve an absolute value equation. Let's say that the absolute value of 2x minus 5 is equal to 3. How can we find the value of x? When dealing with absolute value equations, you want to set the inside part equal to two things, positive 3 and negative 3. So you can get two answers. So we're going to add 5 to both sides. 3 plus 5 is 8. So 2x is equal to 8. Next, let's divide both sides by 2. 8 divided by 2 is 4. So that's the first value. Now let's get the next one. Let's add 5 to negative 3. Negative 3 plus 5 is 2. And then let's divide by 2. 2 divided by 2 is 1, so that's x. Now you can check your work. Let's confirm that these two values are indeed correct. Let's replace x with 4. 2 times 4 is 8, and 8 minus 5 is 3. The absolute value of 3 is 3. So these two match. Now let's replace x with 1. So 2 times 1 is 2, and 2 minus 5 is negative 3. The absolute value of negative 3 is positive 3. So that's why we have two answers. Let's try another example. Let's say if we have 2 times the absolute value of 3x plus 4 minus 5 is equal to, let's say, 9. Go ahead and find the value of x. So at this point, you don't want to write two equations just yet. You want to get rid of the 2 and the negative 5 on the left side. So let's begin by adding 5 first. Nine plus 5 is 14. So this is what we have. Next, divide both sides by 2. So the absolute value of 3x plus 4 is equal to 14 divided by 2, which is 7. Now at this point, this is when you want to write two equations. When you only have the absolute value on one side and a number on the right side and nothing else. So the first equation is 3x plus 4 is equal to positive 7. And the second equation, everything on the left side, we're going to keep it the same, but on the right side, we're going to change the sign. We can make it negative 7. And now let's find a value. Okay, what just happened? Let's find the value of x. So let's subtract both sides by 4. 7 minus 4 is 3. And 3 divided by 3 is 1. So this is the first answer. Now here, let's subtract by 4 again. Negative 7 minus 4 is negative 11. So x is equal to negative 11 over 3. And that's it. Now I'm going to show you an online algebra course that you can use to help you with other topics. So if you go to udemy.com, and just type in algebra, and the course that I created will come up. And it's basically this one with a black background. So if you go to it, you can see an overview. And if you go to course content, you can see a list of topics that are in this course. So I have basic arithmetic, addition, subtraction, multiplication, things like that. If you want a review of fractions, you can look at section 3, solving linear equations. You have a multiple choice quiz as well, order of operations, graphing linear equations, linear quantities, absolute value expressions, and there's more, polynomials, multiplying, dividing, things like that. A whole section on factoring, that's a big thing in algebra. And then you have systems of linear equations, solving by elimination, substitution, even graphing those things. And then you have quadratic equations, rational expressions, radical expressions, and then complex imaginary numbers, exponential functions, logs, how to simplify them, functions in general like inverse functions, composite functions, and then conic sections, graphing circles, ellipse, parabolas, hyperbolas. There's 2 video quizzes on that. And finally, arithmetic and geometric sequences. So if you need help in any of these topics, feel free to check out this course when you get a chance. Now, how can we solve an equation that has an absolute value expression and at the same time an inequality? So let's say that 5x minus 4 is greater than or equal to 21. What should we do? So we still need to write 2 equations. The first one is going to be the same, but the second one, we need to change the inequality and positive 21 into negative 21. That's the difference. And then we'll solve both equations. So let's begin by adding 4. 21 plus 4 is 25. And now let's divide both sides by 5. So x is equal to or greater than 5. Over here, let's add 4 again. Negative 21 divided by 4 is negative 17. And then we'll divide by 5. So x is less than or equal to negative 17 over 5. (17 over 5), that's about negative 3.4. So now let's graph it. So x is equal to or greater than 5. So we're going to have a closed circle shaded to the right. X is also less than or equal to negative 17 over 5. So it can be any one of these expressions. By the way, how would you solve an equation that looks like this? Let's say that on this side it's 14 and on this side it's negative 2. So let's say 4x minus 6 is greater than negative 2 but less than or equal to 14. How would you solve such an equation? What we could do is add 6 to all three sides. Negative 2 plus 6 is 4, and in the middle all we have is 4x, and 14 plus 6 is 20. Now the last thing we need to do is divide everything by 4. 4 divided by 4 is 1, 4x divided by 4 is x, 20 divided by 4 is 5. So x is in between 1 and 5. So let's say this is 0, here's 1, and here's 5. So x is greater than 1, but not equal to it. So we need an open circle shaded to the right. X is less than or equal to 5. So we need a closed circle shaded to the left. So it's between 1 and 5. But at 1, we have an open circle, and at 5, we have a closed circle. Now let's talk about how to factor equations. That's another technique you need to know how to do. So let's say if you have the expression x squared minus 25. How can we factor this expression? Whenever you have the difference of two squares, you can factor it using this expression, a plus b times a minus b. So the square root of x squared is x. The square root of 25 is 5. One side is going to be positive and the other side is going to be negative. That's how you can factor x squared minus 25. Try this example. X squared minus 36 and 4x squared minus 81. So the square root of x squared is x. The square root of 36 is 6. So it's going to be x plus 6, x minus 6. Now we're going to use the same technique to factor 4x squared minus 81. The square root of 4x squared is 2x. The square root of 81 is 9. So it's going to be 2x plus 9 and 2x minus 9. Try these. 9x squared minus 64 and 16x to the fourth minus 81. The square root of 9x squared is 3x, and the square root of 64 is 8. So we're going to have 3x plus 8, 3x minus 8. Now for this one, the square root of 16x to the fourth is 4x squared. The square root of 81 is 9. So it's 4x squared plus 9, 4x squared minus 9. But here we have another difference of perfect squares. So we can factor that even further. We can't factor 4x squared plus 9 without introducing imaginary numbers. So we're going to focus on this one. The square root of 4x squared is 2x. The square root of 9 is 3. And so one is going to be positive and the other is negative. Let's say if we wanted to factor a trinomial, x squared plus 5x plus 6. How can we do so? So you need to find two numbers that multiply to the constant term but add to the middle coefficient. So what two numbers multiply to 6 but add to 5? 2 times 3 is 6, but 2 plus 3 is 5. So the answer is just going to be x plus 2 times x plus 3. Here's another example. X squared plus 8x plus 15. Try this one. So find two numbers that multiply to 15 and add to 8. So this is going to be 5 and 3. 5 plus 3 is 8. 5 times 3 is 15. So the answer is x plus 5 times x plus 3. Now what about this one? X squared minus 5x and let's say this is negative 36. So what two numbers multiply to negative 36 but add to negative 5? 9 times 4 is 36 and they differ by 5. Now one of these numbers has to be negative. It can't be 9 and negative 4 because that adds up to positive 5. But negative 9 and positive 4 adds up to negative 5. So the answer is going to be x minus 9 times x plus 4. Now let's say if we have a quadratic equation. X squared plus 4x minus 21. Let's say it's equal to 0. Solve this equation by factoring. So two numbers that multiply to negative 21 are 7 and negative 3. And these two, they add up to 4. So it's going to be x plus 7 times x minus 3. Now to solve it, set each factor equal to 0. So if we subtract both sides by 7, we can see that x is equal to negative 7. And here, if we add 3 to both sides, x is equal to 3. So these are the two answers.